Hmm? You apply all concept. Again, don't think very ideally. Okay, you apply all concept whatever you have learned. Okay, speak up. Look at here. Potential is infinity only at x equal to b. Am I right? So that's why you can expect some sharp edge at x equal to b. Wave function should be always continuous. Am I right? That wave function will have sharp edge at x equal to b because that is the point where potential is touching infinity. Everywhere else, it should not have any sharp edge. It has sharp edge here. I will remove this one. At x equal to 0, it has sharp edge. I'll remove this one. Why? At x equal to 0, potential is finite only, am I right? Maybe discontinuity, but potential is not going to infinity. Okay, I mean, I'm using only those two, what you call, thing that in Griffiths he mentioned, am I right? Psi is always continuous, d psi by dx is continuous, except at the point where potential is infinite. I'm just applying that. Okay, speaker. Now, okay, what is the energy? Energy less than V naught, am I right? If energy is less than V naught, you have incoming wave, you have reflected wave. Okay, here you have A e power ikx plus B e power minus ikx. If you take mod square, it will be sinusoidal. Okay, here it is classically forbidden region. It is e power kappa x, e power minus kappa x. Okay, so but you make it smoothly varying. Don't put any sharp edge here. Why? Derivative should exist actually. So derivative should be continuous. Okay, now in that region, in this region, what would happen? Again sign. Speak up. Again sign somehow. So, but what I'm saying is once you go here, so this have a discontinuity, am I right? This also have a discontinuity. Then only option is this one. Okay, he didn't. Only possible option is this one. I mean, he should have. Okay, he plotted mod psi square actually. Okay, so here he should have shown one sharp edge. Am I right? Like this. Sharp edge may be there. Okay, but it looks like he wrote like this. Isn't it? It looks like, okay, he wrote like this. Yeah, it should be 0, but yeah, I mean, it should be 0, but sharp edge must come over there. And sharp edge should not come anywhere here. At x equal to b, your potential is infinity, am I right? You just check your cos and sine function, am I right? It was going suddenly 0 like this. It has a sharp edge, am I right? I have shown derivative discontinuity for a particle in a box function, okay, at the edges. Okay, speak up. See this one. Go with appropriate one. Okay, now look at here. If you take mod square of this one, it may have some constant factor. He didn't care about that constant factor. Don't be too ideal. I mean, you will say all questions are wrong if you are too ideal. Is that okay? Speak up. So you give this question to pure theoretician. Okay, they'll figure out some mistake in all question. Okay, so don't go too ideal, but apply concept. Apply concept. Okay, what we have learned. So sharp edge should not come here, isn't it? And wave function should be always continuous. Okay, those 2 points that is mentioned in Griffiths in some box or something. Speak up. Psi is always continuous. D psi by dx is continuous except at the point where potential is infinity. Now he didn't care about this one, this part. Don't worry. So don't worry. Okay. So here it's a kind of exponential function, Okay. Actually, it's a combination exponentially increasing as well as decreasing function. Okay, but it's a kind of exponential function. Again, sinusoidal here because it's a kind of free particle here. Isn't it? So potential is 0, and again wave function should be 0 here. Okay, so C and D you can quickly eliminate because wave functions are discontinuous. How I eliminated B? Because he shown one sharp edge here. I don't expect any sharp edge at the point where potential is finite. I mean, amplitude decrease, that you need to take the idea that, okay, you are shooting the particle, suppose 100 particle, okay, only some particle will go here, some particle will reflect back. That's why amplitude decrease. You can think like that. How I eliminated this one? Sharp edge should not be there here. Speak up. Sharp edge means derivative discontinuity. Speak up. So it should be smooth like this. Okay. Speak up. So don't be too ideal. Okay, they may miss something when they create very complex question. Okay, they may miss something. Okay, speak up. But don't be too ideal and choose the appropriate option. Apply the concept. Okay. Yeah. Here, this region. In this region, okay. I mean, you just take mod square of this one. It will have one constant factor. Hmm? Check that out. I mean, in Jatili, he plotted slightly above only, am I right? He didn't touch the. Huh? Mod A and mod B again. Okay. Eq- Equal, then it will be cosine square. Am I right? If A and B are equal, it's again cosine. Am I right? Yeah. I mean, incoming and reflected one B is slightly lesser than A. Am I right? Usually. Okay. Speak up. So I mean, if A and B are unequal, okay, then it will have one shifting. I mean, it will shift slightly upward. That's what I feel. A B or something. That's right. Hmm? But he might not have taken care. Don't say again. That's also wrong. Okay. Choose the appropriate option. Quickly, you can eliminate these two. Wave function is discontinuous. Okay. Among these two, why it should have a sharp? Among these two, what is the difference? Main difference is here only. Am I right? Isn't it? Main difference is here only. Am I right? Eliminate the option. Okay. Speak up. Fine. I mean, you need all concept to solve the problem, but while solving the problem, don't what you call, don't behave like a theoretician. Okay.